Hi everyone, welcome back to PW International Boards. Friends, in today's class, we are going to start a theoretical concept, and that is going to be your very first chapter for Physics Cambridge IGCSE, and that is physical quantities and measurement techniques, right? So in today's class, we are going to talk about all the most essential topics from this chapter, and followed by that, we are going to solve some previous year questions, right? So without any delay, first let me explain what are going to be the different topics for today's class, then we are going to start the lecture, right? So in today's class we are going to talk about, first of all, obviously we are going to discuss what do we really mean by physical quantity. Although we all know that this is a very easy topic, and I mean, there's no chance that in paper a question will come that define physical quantities. But if we are starting a chapter whose name is physical quantities, let's start with what do we really mean by physical quantities. Then after that, we are going to talk about types of physical quantity, and then the next topic is actually quite important. And from this, you get a lot of questions. So this is going to be really important for you, and we need to remember units in different systems, right? So we are going to talk about different system of units like SI system, CGS system, FPS system. So you need to remember all of those things. The next topic is going to be even more important. So volume is actually one of the most important topic from this chapter. So this is going to be very important. You are going to find maximum number of questions from this single topic when you are going to go through the past papers, right? Please, if you haven't seen till now, we have uploaded a lot of past papers from previous years. You can check the playlist for physics, chemistry, maths and biology, right? With that, let's move to the next two topics. The next two topics are going to be scalar and vector quantities and addition of two perpendicular vectors, right? Now these two topics are only for extended students. All right, so these are going to be the topics for today's class. Let's start the class. Let's start with discussing what do we really mean by physical quantity, right? Now in the easiest way, we can define physical quantity as these are those quantities which can be physically measured, or we can actually add something to this point, like these are those quantities which can be physically measured using an instrument. Or all right, so it is the easiest way. For example, as this pen, so I can actually physically measure the mass of this pen, or I can physically measure the weight of this pen using this pen and an instrument, which in this case is going to be a weighing machine. Or I can physically measure the length of this pen, and in this case the instrument is going to be a ruler, right? Or I can physically measure the volume of this pen, which is in this case the instrument is going to be a measuring cylinder. But can you measure anger? Can you measure the can you measure your hunger? No, right? So not all quantities are measurable. That's why we call these quantities as quantifiable. So quantifiable means that these we can actually add a number to these things, right? So the definition is going to be really easy. We are going to just say that these are those quantities which can be physically measured using an instrument, right? We can actually discuss about various examples, like when I told you that we are going to actually measure the length of this pen. Let's suppose, for an example, the length of this pen comes out to be 10 centimeter. Now it's quite easy to understand, right? I mean, we actually do this all the time. But if you're going to closely see this 10 centimeter, this thing is actually the physical quantity. That means physical quantity is actually made up of two things, and the two things are, one is the number. So this is going to be called as the numerical part, And the next thing is actually something that is called as unit. That obviously we are going to talk about it, right? So a physical quantity is a combination of two things. One is a numerical part and the second is a unit. What is unit? We are going to talk about it. But for now, let's move ahead. I have got everything written for you, and you can also find these notes and on www.pw.live, right? So how to get to there? You have got a video on our YouTube channel. Find that video. It will actually walk you through to every steps, and you can actually get these notes over there, right? So let's read what do we have over here. The quantities which can be measured by an instrument and by means of which we can describe the laws of physics. So this is another part, right? You can also define physical quantities by this, that using these physical quantities we can actually describe the laws of physics. So this is very good. They are quantifiable and can be expressed using a numerical values, right? So what are numerical values? The numerical values are the magnitude. We also call these things as magnitude. All right, with this, let's move to a next topic, that is that when we are going to talk about physical quantities, we have already said that physical quantity is represented by a value obtained through multiplication of a numerical magnitude and a specific unit. Let's talk about certain examples. Now I have got like various examples over here. Like we have got mass, we have got length, we have got time, temperature, electric current, amount of substance, light intensity, force, velocity, and now you get the point. I mean, I can read out these names all day, right? We have got like numerous of these physical quantities, but we have actually selected, and when I say we, the scientists of the, let's say, of past have decided certain special quantities. They have given a special status to certain quantities. What are those quantities? Those quantities are mass, length, time, temperature, then you have got light intensity or amount of substance, you have got light intensity, and last you have got mass, length, time, and you have got current, electric current. So I have written 7 quantities over here. These have got the special status and these are known as fundamental quantities. There is no concrete reason behind choosing only these 7 quantities as fundamental quantities, but we can define what do we mean by fundamental quantities. These quantities are independent of each other. I mean, we do not require any other quantity to define what mass is, right? But let's suppose you want to define speed. So speed is defined as distance traveled by a body in unit time, isn't it? So speed is actually distance traveled, distance upon time. So speed is not a fundamental quantities, right? Speed is derived using 2 other quantities which are distance and time. So please remember these as the fundamental quantities. Moving on, when we are going to talk about types of physical quantities, that's what we are going to actually define. We are going to say that we have got mainly 2 different types of quantities. One are fundamental quantities and the next one are called as derived physical quantities. So now it becomes more clear what do we mean by fundamental quantities. Those quantities which are not derived quantities are fundamental quantities, right? For example, we have already talked about this: mass, length, time, temperature, amount of substance, light intensity, and current. Let me just write I for current. right? And then all the other quantities then this are actually known as derived quantities. What do you mean by derived quantities? For example, let's say that we are talking about, let's consider any physical quantities. Let's say we are talking about force. So force is mass times acceleration. Let's talk about acceleration. Acceleration is change in velocity upon time. Let's talk about velocity. Velocity is change in displacement upon time, right? And let's talk about time. Time is nothing but time is time, right? So time is a fundamental quantities. All other quantities are going to be called as derived quantities. There are few other quantities as well, but you don't have to worry about them as such. These are known as supplementary quantities, where we are going to talk about angles. So in supplementary quantities, we are going to basically say, here we are going to just talk about the angles, right? So now, as we have covered what do we mean by fundamental quantities, what do we mean by derived quantities, let's see their notes as well. Certain physical quantities have been chosen randomly. So this is the important thing that you need to know. These are chosen randomly or arbitrarily, and their units are used for expressing all other physical quantities, and these are known as fundamental, absolute or base physical quantities. Please remember these names. All other physical quantities can be expressed in terms of fundamental quantities, hence known as derived quantities. They are independent of each other and cannot be obtained from one another. So we have covered this point as well. Moving to a different topic, related topic, that is unit. You remember we talked about a physical quantity is made up of two things. One is a numerical part, next is the unit. So let's talk about the unit. Now when we are going to talk about unit, we are going to say measurement of any physical quantity is terms of internationally accepted certain basic reference standard. So these are nothing but these are standard. For example, I just now told you that let's suppose the length of this pen is, let's suppose I invented a certain unit. Let's suppose I invented the unit is, let's say this is this is exactly to the length of my palm, right? So I would say that the length of this pen is actually is equals to my hands, my length of my palm. Now this is not internationally accepted. Obviously this is not at all rational to assume certain units like this, to assume certain standards like this. That's why to communicate effectively we have actually selected some of the internationally accepted units, right? And those internationally accepted standards are called as units. So you can define it like that. The units for fundamental, now here the things are quite easy. We talked about physical quantities. Physical quantities are fundamental quantities and derived quantities, right? The units of those fundamental quantities will be known as fundamental units, and the units of those derived quantities will be known as derived units. So this is one of the most important thing, that fundamental or base quantities, those units are going to be called as fundamental or base unit. Other physical quantities can be called as derived units, right? Now when we are going to talk about units, we have actually created some systems. Now you can assume these systems like a bucket. Now what are these different systems? These different systems can be, one of the example can be a CGS system. Let me write it again. One of the example is CGS system. So in CGS system, when you are going to talk about length, it will be measured in centimeter. When you are going to talk about mass, it will be measured in gram. When you are going to talk about second time, it will be measured in second. Obviously we have four more physical quantities that are fundamental, but we have again randomly chosen three of the fundamental quantities. Those are mass, length and time, which actually the reason could be those are the most commonly used physical quantities in mechanics or in physics, right? That those are mass, length and time, most commonly used, right? So in this bucket, in the CGS bucket, we actually write certain physical quantities with certain special units, right? Now the another bucket can be SI system, which is actually the most popular and most internationally accepted unit system. The full form of SI system is International Standardized Unit System. In this SI system, or in this system, which is also known as MKS system, MKS system, and in this one, M will basically measure mass, and M will basically measure the length, that's going to be in meter. For K, it's going to be kilogram, that's going to be for mass. And second, we don't have any variation over here, so second is going to be used for time, right? Moving on to next, whatever we have written till now, let's move to the next slide and let's see. So here we have got different physical quantities, and if you pay attention, these are the fundamental quantities, right? Like mass, length, time, electric current, temperature, amount of substance, and luminous intensity. And we have got base unit assigned for them. So those quantities were called as base quantity, and these units are called as base unit. By the way, all of these units are part of the SI system, so make a note of it. And why it is so important? Because whenever you're going to write answers in your physics paper, you are going to always write in a same system. I'll give you an example. Let's suppose somebody is in a question, they are asking about work done, and you know that work done is actually written as force times displacement, right? And they have told you that the force is actually in newtons, it's 10 Newton, and distance is in centimeter, right? So it's going to be 1 centimeter. So the answer is going to be 10 Newton centimeter. But what they have done is they have written it like this, that you have to fill your answer over here, but you have to write the answer in Newton meter. So you have to pay attention to what should be the final unit of your answer. So if you want to convert it, you will quickly convert it into 0.1 Newton. All right. With this, let's move to the next slide. What do we have over here? We have got different systems with their name. So we have got CGS system, whose another name is Gaussian system. We have got MKS system. I have already explained you. Another name is SI system. More popular name is SI system. And the another one is FPS system, which is also known as British system. So we have already discussed the first two. Let's discuss the last one, that is FPS. For FPS, for length we are going to use foot or feet, and for mass we are going to use pound, for time we are going to use second, right? Now we can use we can actually write some of the derived units also, derived physical quantities also. For example, as for work and power, right? Obviously we have got many more, but we are going to start with these ones only. Now we are going to talk about principal system of units. In this, we are going to talk about some prefixes and their multiplier. Now this is very easy. You must have, we always use like centimeter, right? We always use 1 centimeter. But I mean, we often don't realize, but this centi is nothing but it is a prefix, right? And centi has got a multiplier of 10 to the power minus 2. So this is going to be, this can be written as 10 to the power minus 2 times meter, and which is going to be 0.01 meter, right? Similarly, always remember these prefixes are going to be same. So if you are going to talk about like milli, so for milli, always the multiplier is going to be 10 to the power minus 3. So if somebody is telling you to write 1 millicentimeter, that is 1 mm, so that's going to be 10 to the power minus 3 meters. Or if somebody is telling you to write 1 milligram, so that's going to be 10 to the power minus 3 gram. All right. Similarly, the next multiplier is going to be, the next prefix is going to be micro, denoted by a Greek letter mu, whose multiplier is 10 to the power minus 6. Nano, for nano we have got 10 to the power minus 9. For pico we have got 10 to the power minus 12. Now we have got certain multiplier which are obviously greater than 1. and we start with kilo, that is 10 to the power 3, that's kilogram. Then we have got mega, that's for 10 to the power 6. We have got giga for 10 to the power 9, and we have got tera for 10 to the power 12. Now we have left one, that is deci for 10 to the power minus 1, right? So deci is also very important, deciliter, decimeter, decimeter cube. So this thing is important, deci stands for 10 to the power minus 1. Moving on, next is the important topic that we were talking about when we started the class, that's going to be volume. When we have volume basically it basically represents the quantity of three-dimensional space occupied by an object, right, or enclosed by a closed surface. It measures the amount of space within a three-dimensional object or a container. So for example, if you are going to talk about a, let's say we are talking about a sphere. Let's say we are talking about a sphere like this. So what's the space? What is the space occupied by this? So the volume of a sphere is going to be 4 by 3 pi r cube. If we are going to talk about, let's say, a cuboid, let's say we have got a cuboid of edge length a, the volume of this cuboid is going to be a cube. So basically it's the multiplication of the three dimensions, right? But it's not that easy if you're not going to get a regular shape. These are called as regular solids. These are called as regular shaped solids. So if you're going to get a regular shaped solids, it's best that you're going to use a mathematical formula and you can get what volume they have, right? But what if we are getting a irregularly shaped solid? For those we actually use certain different things, certain device that we are going to just talk about. But before that, we have talked about the formula. Let's also talk about their units. Now I told you that the volume is actually the multiplication of the three dimensions. In this case, we actually read one example as 4 by 3 pi r cube. Now please understand that here the 4 by 3 and pi is a constant, so it is just a number. It is just a number. And unit of one of r is actually meter. So this is going to be meter cube, centimeter cube, millimeter cube, any system that you want to pick, right? So for volume, the volume is expressed in cubic units such as cubic meters, cubic centimeters, or cubic inches. Commonly used to describe the capacity of containers, the amount of material in solid object, or the volume of liquids and gases, right? Moving on to find out how to measure the volume of irregularly shaped solids. And now this is the thing that we were talking about. This is actually important, right? So please understand that this is an important topic. So this is called as measuring cylinder. This is something as called as measuring cylinder, and how to use it. Now in this measuring cylinder, we have got some liquid filled. Let's suppose it's water, and it has got some level, and this is its initial level, and this is called as meniscus. That means the curved part of the top layer is called as meniscus. And let's say this is reading R1, right? Now suppose that we have got an irregularly shaped solid, and I'm going to make one for you. This is an irregularly shaped solid, and we want to actually calculate the volume of this solid. So what we are going to do is we are going to drop this solid over here, and obviously we are going to notice one thing, that the volume of this water or any liquid that is kept in this is going to rise up, and let's say it has risen up to this level, and this is the reading R2. Now it's quite easy. The volume of the solid will be actually R2 minus R1. That's it, right? So this is that simple, and trust me, and you must also know this, many questions do come from this part of this chapter, that is volume. Many questions come like how you measure volume of an irregularly shaped solid, or which type of instrument you want to use, you would use. So you would use a measuring cylinder, and that's how you use it. Also we are going to find density through measuring cylinder. We are going to also require a balance for that. We are going to talk about that in when we are going to reach mass and density. So we are going to cover all of these topics as well, right? Moving on to the next part. This is only for extended student. So please pay attention for all of the students who have opted for core physics. This is not going to be part of your syllabus, right? Now we are talking about scalar and vector quantities, how we are going to define these quantities. Although we actually discussed what are types of quantities, so we have got some fundamental quantities and we have got some derived quantities. Now we are categorizing physical quantities on another parameter, whether they require direction or not to define themselves, right? So again, physical quantities can be defined as scalar quantities. So scalar quantities are those quantities which only have magnitude, to define themselves, right? Or in other words, we can write they don't have direction. Moreover, you can give many examples for scalar quantities. Examples can be, you can start with mass, length, time, and after this you're going to say speed. Then you can talk about power, work, and minimum, right? So these are some of the physical quantities which are scalar. That means we do not require direction. It means that you can also assume it like this, that let's suppose we have got a 1 kg block over here. We have got a 1 kg block kept over here. Now it doesn't matter in which direction you want to measure the mass of this 1 kg, right? Direction has got to do nothing with the mass of 1 kg, right? But the another type of quantities which are known as vector quantities, they have both magnitude as well as direction to define themselves. Now what do you mean by magnitude? You remember that numerical part, right? That numerical part is the magnitude. So if somebody is saying that 1 kg, that 1 is the numerical part, that's magnitude, kg is the unit, we talked about it, and it has got no direction. But when we are going to talk about magnitude, they have magnitude as well as they have got direction. So now, but how you are going to define direction? How you are going to express direction? So directions can be actually expressed as, in physics, they are usually expressed as in the form of either angle. It can be expressed as in the form of angle, or you can say, for example, let's suppose we are saying that we have got a car, which is moving in with 3 meter per second due east. So that's how you write the direction, due east. East is the direction, right? That's how you're going to say that we are talking about a vector quantity. So 3 meter per second, 3 is the magnitude, meter per second is the unit, and the direction is east, right? So we are going to talk about the directions when we are going to talk about force and all, right? So for now, that's what the vector quantities are, and then we are going to talk about addition of two perpendicular vectors. Now, before writing addition of two perpendicular vectors, let's say we want to represent vectors. Now vectors are represented as arrows like this. They are going to be represented like these arrows, right? So the length of these arrows is going to be the magnitude of the vector. I'll explain it in a different way. Let's suppose this is a force. This is force of 10 Newton. And let's say this is F1 force. You're trying to apply a force on a body. Let's say we have got a body kept at this point. We have got a body kept at this point, and you're trying to apply a force of 10 Newton in this direction. So it means that the length of this arrow is going to tell you that the magnitude is 10 Newton. That means this is of 10 units. Now a vector is represented by an arrow where this is known as head of the vector, this is known as tail of the vector. All right, and let's suppose we have got another vector, and now because we are just talking about addition of two perpendicular vectors, we are going to draw another vector as something like this. And let's say this is another vector and this is F2. It could be anything. Let's say this is of let's just suppose this is of 30 Newton. All right, now we want to add them vectorly. Now please understand, when we were talking about scalar quantities, and let's say I told you that we have got another body whose mass is actually 0.5 kilograms. That means half kg. Now you tell me what is the mass of this total arrangement. So you are going to say the total mass is going to be 1 by 2 kg plus 1 kg. That gives you 1.5 kg. Or for example, as when I am going to say that I have the temperature has been raised from 10 degrees Celsius and the increase is actually of 5 degrees Celsius. What is the final temperature? You are going to say 15 degrees Celsius. These types of additions are known as scalar addition. That means 2 plus 3 is 5. The addition that you have been learning so far. But when you want to add vectors, vectors are not added like this. Like for example, as 30 plus 10 are not going to be 40 in this case. They will be 40 Newton in a specific case, but right now when they are perpendicular, they are not going to be 40 Newtons, right? So with this, we are going to actually use a law which is known as law of vector addition, also known as law of triangle. What does law of triangle say? Law of triangle basically says the resultant of these two vectors are going to be in between of this, something like this. And let's say the magnitude of the resultant vector is FR. And it will be written as FR equals to the square root of the squares of F1 plus F2. Doesn't it look similar? Yes, you're right. It is actually nothing but a Pythagoras theorem, right? That's why we actually call as law of triangles. Although law of triangle is something else. Law of triangle is if you have got a vector like this, let's say this is vector A, and you join the tail of another vector B, something like this, then the third side of this triangle is going to give you the sum of these two vectors. So this is what the law of triangle says. Vector A plus vector B will be vector C. But in this case, when these vectors are going to be perpendicular, you can easily find the magnitude using this formula. And we'll just substitute the values over here. So this is going to be square of 10 plus square of 30. So this is going to be 900 plus 100. That's going to be 1000. And we can write it as 10 root 10 Newton. That's it. So that's how you are going to add addition of two perpendicular vectors. What I meant over here, this is the law of triangle, law of vector addition. All right. With this, let's move to some questions of past year. So the first question is from October-November series 2023, and it is part of paper 1. And the question says, in order to determine the period of a pendulum, a student times one complete swing of the pendulum using an analog stopwatch with a second hand. which change of method produces the greatest improvement in accuracy? All right. So now basically what they are trying to say is they are actually talking about how to improve the accuracy of a measurement, right? So we talked about measuring certain physical quantities. Now let's talk about how to increase the accuracy for it. The answer for this one is going to be accuracy can be increased by taking average values. Now, what do you mean by average values? By meaning of average value, let's say that we are doing an experiment in which we are calculating the time period. So let's say these are the number of experiments. This is, let's say this is experiment 1, 2, 3, 4, 5, 6, and you're going to get different values over here. Let's say the time period is coming out to be 5 seconds, 5.1 second, 4.9 seconds, 5.01 seconds, 5.02 seconds, 5.03 seconds, right? Now what you're going to do is you're going to add all of these values. So that means 5 plus 5.1 plus 5 plus 4.9 and so on, all the values. The last value is 5.03 divided by how many total number of observations were here. So 6. So total number of observations is 6. So this is how you calculate the average value. Now this is how you're going to increase the accuracy, right? So asking a friend with a shorter reaction time to take the measurement, this won't help, because again, if you're going to ask a friend, human error can come into account, right? Measuring the time for 100 swings of the pendulum and dividing it by 100, this is absolutely correct. The more the number is for the taking the measurement, the accurate the answer will become, right? So the correct answer is going to be option A. Correct answer is going to be option B. Why C is not correct? Because they are measuring the time for half swing of the pendulum and they are doubling it. Again, if you are getting an error in the half of the swing, you are going to just double it and still the error is going to remain the same. Using a digital timer will also, there will be a time lag between the response. So again, that there will be a certain error in that as well. Moving on to the next one. An object is suspended from a spring balance on the earth. The same object is suspended from the spring balance on another planet. Which statement explains the difference between the two readings? Now, although this, we are going to again talk about this question in mass and weight, but because it is related with readings and it is related with measurements, we are covering it over here as well. Now we can see that the reading on another planet has gone down. So with this, we are going to say that the reading on earth is greater than the reading on the another planet, right? Which basically means that the weight on earth is greater than, well, I beg your pardon, reading on earth is actually lesser, right? Reading on earth is actually less. So on another planet, so that means weight on earth is actually less than the weight on another planet. So let's see what options we have got. Both mass and weight of the object are greater on the other planet. Now here is a little spoiler from the future classes. We are going to talk about mass and weight obviously in the next chapter, but for now please understand that mass remains constant. It is nothing but it is the amount of matter contained in a body, and weight is actually mg, right? So when you are going to talk about weight, let's suppose this is the surface of any planet, it could be earth or any other planet, and let's say this is the body and the mass of this body is m. So the gravity is going to pull this body downwards and the force is going to be mass times the acceleration due to gravity at that planet. So mg is actually the weight, and to be precise, weight is actually the normal reaction like this, but we don't have to worry about all of these things right now. So this is the weight. So weight can actually change because weight actually directly depends upon the acceleration due to gravity, or you can simply say it depends on gravity. But mass doesn't depends upon gravity, mass remains same, right? So when they are saying that both mass and weight of the object are greater on the other planet, they are wrong, because the wrong thing over here is that they are talking about the mass. Mass does not change. The mass of the object is greater. Again, this thing is wrong. The mass is not greater. Mass will remain same. The spring stretches more easily when on the other planet. Spring is a physical entity. It stretches because of force, right? So it will stretch with the same easiness or with the same difficulty in whichever planet it is. The weight of the object is greater on the other planet than on the earth, but the mass is unchanged. This is absolutely correct. So the correct option is going to be option D. Moving on to the next one. A student has a bottle of cooking oil. She determines the density of the cooking oil. Which apparatus does she need? Now, if she wants to measure density, we know that density can be written as mass by volume, and we know that mass is measured using a balance and volume is measured using a measuring cylinder, right? So we don't have any use for ruler or thermometer. So the correct answer for this one is going to be a balance and a measuring cylinder, that is option C, right? With this, let's move to next question. Question number 4. A student investigates the oscillation of a mass suspended from a spring. The student pulls the mass down from its rest position P and then releases it so that it oscillates vertically. The student then follows the instructions listed to find the period of the oscillating mass. Again, they are talking about a certain physical quantity. That physical quantity is basically the time period of the oscillating mass, right? And they are saying that they want to find the accurate time period. So whenever they say they want to find the accurate time period, accuracy is linked with taking the average value, right? So the first step is going to be, let's suppose we have got a pendulum like this. A pendulum is swinging over here between the extreme position, something like this, right? And let's say the question says the student pulls down the mass from rest position P and then releases so that it, so let's say this is the rest position and the student releases it over here. So the complete swing is going to be something like this when this pendulum reaches back to point A, right? So the first thing is to actually take the multiple readings, right? Count 10 complete oscillations, divide the time by 10, start the stopwatch as the mass passes through the upwards through point P. So this is the first thing, that at this point start the stopwatch. So this is going to be t equals to 0. Then again when it comes back to the point P, right, then what we need to do is count 10 complete oscillations. So count 10 complete oscillation, that means after 3 we would have 1, and then stop the watch. After 10, stop the watch. Let's say you are getting time as capital T, right? Your reading is R, so do R by 10, R by T. So that's, and the number of oscillations are actually, sorry, the number of oscillations are 10. So the total amount is, let's say, T. So T divided by 10 is going to be your answer. So it's going to be B. That means first it's 3, then 1, then 4, and then 2 divided by 10. Got it? That's going to be the correct answer. Moving on, a student carries out an experiment to determine the density of an irregularly shaped solid. The solid is placed on a balance and reading is taken. The solid is then immersed in a liquid in a measuring cylinder. Which values should be used in the calculation? All right. So value from measuring cylinder, increase in reading after immersion of solid, increase in reading after immersion of solid, and value from balance. So they are talking about actually which value should be used. They are talking about two things, balance and a reading, right? So obviously the reading from the measuring cylinder will be increase in the reading after immersion. So either it's going to be A or B, and when you have got a balance, balance basically measures the mass, so it's going to be option A, right? So it's easy question. Moving on to the next one. How many quantities shown over here are scalars? So scalar quantities, let's figure it out. Obviously mass is a scalar quantity. Momentum is actually written as, momentum is nothing but, momentum is mass times velocity, and velocity is a vector quantity. So momentum will also be a vector quantity. Then density, density is nothing but it is mass by volume. So again mass is a scalar quantity, volume is a scalar quantity, so density will also be a scalar quantity. Then we have got energy. Energy is the ability of a body to do work, and work is actually force times displacement, but here is a catch. Here it is the force in a particular, in the direction of the displacement, right? Or you can say the displacement should be in the direction of force. So this is also a scalar quantity. Please remember, energy and work are scalar quantity. So we have got actually three quantities which are scalar. Moving on to the next one. Which unit is a unit of weight? Now weight is actually, we have already talked about it, weight is actually, generally it is denoted as mg. I am saying generally when the ground is flat. So kilogram is unit of mass, kilojoule is actually unit of work or energy, kilometer is the unit for length, and since weight is actually nothing but it is a force, so the answer is going to be kilonewton, and 1 kilonewton is actually 10 to the power 3 Newton. All right. And basically Newton is nothing but, I am going to also write that thing for you. Newton is nothing but it is kg meter per second square. That means kg stands for mass and meter per second square stands for acceleration. That's what the weight is. That means mass and acceleration due to gravity. Moving on to the next one. Which single apparatus is used to find the volume of a solid cube, and which single apparatus is used to find the volume of a quantity of a liquid? Now for volume of a solid cube, we actually talked about this thing, and it is part of today's theory, today's theoretical part, that when we are going to talk about a volume of a cube, let's suppose we have got a cube something like this. And we know that volume of a cube is actually a cube. So we actually only want to find out the length of this h, that is a. And if we are able to find out just the edge length, we will able to find the volume, that's a cube. And we can find out the length of this edge by using a ruler, right? So the correct answer for this one is going to be, volume of a solid cube will be find out using a ruler. So either it's going to be C or D. Now when you are going to talk about an irregularly shaped solid, right? So a solid cube and it is find to volume of a, or let's say sorry, liquid. So for a liquid you can actually use a measuring cylinder. You can use a measuring cylinder. So the correct answer for this one is going to be option D. Moving on to the next one. Question 9 says the diagram shows a pendulum that oscillates between point P and Q. Which method is used to find the average period of oscillations for the pendulum? We have got options on the another slide. The options are, the diagram shows the pendulum, okay. Measure the time it takes to swing from P to Q. All right. So now the time period is actually, when we talk about time period, time period is the time to complete one oscillation. So it could be something like this. That means from P to Q and from Q to P. This could be one answer. Or one answer could be from Q to P and then from P to Q. And let's say, I mean, you get it, right? Or let's say we have got another point over here as A. It could be like from A to Q, from Q to A. Now that's not correct, right? The another thing is going to be from Q to A, and then from A to P, and then from P to A. That's going to be the correct way, right? So hopefully you have got it. So for this, measure the time takes to from P to Q, that's wrong. Measure the time it takes to from P to Q to P, that's correct. 10 times and divided by 10 times, this seems to almost correct, but we are going to look for the another option as well. Here we are measuring it and we are also taking the average values. Right? So this is absolutely correct. Measure the time it takes to swing from P to Q to P 10 times and multiply that time by 10. You don't have to multiply it, right? Multiplying it will give you the value 10 times bigger plus errors, right? D is measure the time it takes to swing from Q to P. That's also not true. Moving on to the next one. A student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. Well, if they want, if they only have got a measuring cylinder and they have got a balance, so what they can do is, and if they want to find out the volume is found out using only measuring cylinder, right? We don't need balance. So the measuring cylinder containing water only is going to be the correct answer. Moving on to the next one. Which piece of apparatus is used to measure the length of a copper rod of length approximately 2 centimeter? The answer is going to be ruler. So yes, these types of questions do come in IGCSE paper. It is part of May-June series 2023, paper number 1, variant 3. Right? Moving on. The times for 10 swings of a pendulum are measured. What is the average time for one swing? So all you have to do is you have to just add them. So the final answer is going to be 10.12 plus 10.48 plus 10.24 whole divided by 3, because that's what the correct answer is. That how many number of experiments we took, right? And because you can use the calculator, you can find out this answer. So the correct answer according to calculator is 10.28. So it's 10.28. That means D option is going to be the correct one. Moving on, friends, I think we have almost solved all the questions. That will be all for today's class. We are constantly uploading more and more questions over here. We are constantly uploading more and more past papers, and we are going to be also uploading some theoretical lectures like we did today, right? So we are going to bring back more lectures for you. If you have any query, if you have any problem, please write down in the comment section. We'll get back to you. Till then, take care. Thank you so much. Bye bye.